Alright, so today we're going to talk about stability. So stability of a control system is basically what you'll design so that when a system is exposed to a transfer function of some sort, it's going to return to a stable state, that being 0. So for example, if you have your system here and then it's exposed to transfer function, like an impulse, right? Goes up like that. You're going to want the system to respond in such a way that it will kind of stabilize around that point. So the difference between where the system's at and where it's supposed to be at is 0 or near 0. So one of the ways, an example of this problem would be, so if you have like a ball and you're going to push it, it's going to roll. So to add stability to that, you could put it in kind of a half pipe thing right here, right? So now if you push it, it's going to go out, but it's going to return to that 0 position there. So this would be a stable system. An unstable system would be, I guess, instead of having the ball in a kind of a half pipe, you have it on top of a hill. So if you push it, it's going to go out to infinity and it's not going to be stable. So how do we determine that? So when you have your system, you're going to have your plant there, right? And then you'll have your control system for a closed loop system here, right? And then that's what your sensor is. And then there's your control element here that kind of controls it. So what you're going to do, so you get a function, we'll call it g of h of s. And that's kind of the system that represents the function. So when you have stability of that, the function there is going to look something like this. So it's going to be 1 over s plus 1. So it'll look something like that. So you have 1 over s plus 1 times s plus 2. And then you can graph that on kind of an Nyquist plot. So as long as the zeros on the bottom, so when the function is equal to 0 are on the left-hand plane, that's going to be stable. So if you add something, say you add 1, you multiply by 1 times s minus 1, you're going to get a pole that's going to be in the right-hand plane, which is going to make it not stable. So that's how you determine stability of a function.